doing what's called a blue bottle experiment. This is one of those experiments we were going to be doing this year, but we didn't get around to it due to this shutdown. I've got several ingredients here for the reaction, and we're not going to get into like the nitty-gritty details of the chemical reaction today, because a lot of it deals with organic chemistry, because we have here, you'll see here, C6H12O6. That is glucose. And glucose is sugar, and or dextrose here in this case. And so this is basically sugar, and that is organic. And organic chemistry is a bit more complicated. It has more complicated structure. So we're not going to get into the nitty-gritty details of the chemical reaction of this equation. But what I do want you to pay attention for are signs of when a chemical reaction is occurring. If you'll remember, we need to, let's review real quick. There are 4 different things that we've talked about when a reaction is occurring, or if a chemical reaction is occurring. And that is, the first one is there a color change. The second one, is there energy taken away or added? So is the reaction hot or exothermic, or is the reaction endothermic or cold? Then we've got a third one, which would be, is a precipitate formed or a solid formed from two liquids? But the last one being bubbles are gases produced, okay? So let's see. Throughout this reaction, I've got several different things that we'll be measuring that. I've got a thermometer. We've got, again, dextrose, C6H12O6. I've got sodium hydroxide side here, which is NaOH. And then just pure distilled water, H2O. The last ingredient I have is this methylene blue. It's like a dye, all right? I have them all covered because I had them all pre-measured out before, and I didn't want them to absorb any moisture or anything. So right now they're all covered with some saran wrap. The dye that I made, this methylene blue, it comes in a powder, and you have to add ethyl alcohol to it. Alcohol evaporates a lot faster, so it wasn't so much that I was afraid of moisture getting into this one as I was afraid of moisture getting out of it. Let's start with the first step in this reaction. The first step in this reaction was I took sodium hydroxide, and this sodium you can see I have to knock it around here because it's absorbed moisture. That's what I was trying to avoid with this case. But the stuff that I come with is in this like pellet, or I don't know how to put it, but they're really big chunks of sodium hydroxide, and we don't want them in really big chunks because then it takes longer for it to dissolve in water. What I did is I took a mortar and pestle, and we've used this before when we were making gunpowder, and I just kind of powderized it up a little bit, not a whole bunch. I don't want too much powder, because the thing with sodium hydroxide is that it's very corrosive in a lot of drain cleaner, okay? And so it's really good at dissolving biological materials like hair and oils and stuff that we secrete. So you don't want to get this stuff on your hands. Safety first. You notice I'm also wearing goggles. Safety goggles. And I'm wearing safety goggles today not only because I have corrosive materials, but I also have glassware. And if I break any glass, I don't want any of this glass getting up into my eyes. So what I'm going to do is dissolve the sodium hydroxide in the water. And before I do that, let's get a base temperature of the water, which should be about room temperature. So right now, yeah, we're looking at 21 degrees Celsius. Okay. That's just room temperature here. All right. So now let's add our sodium hydroxide. Now it's going to be very important that I add this and try not to breathe any of the powder in. So as soon as it pours out, I kind of close my hand up over it. Add the top, and let's give it a good shake. Now, I can already tell you right now this feels warm to the touch. So I think we're gonna have a temperature change here. or it definitely feels exothermic. And let's go ahead and get our temperature. Oh yeah, it's definitely exothermic. We've already risen several degrees here. This is 20, 29, almost 30 degrees Celsius. 29, almost 30 degrees Celsius. So we definitely have an exothermic reaction. The next step in this reaction is to add your glucose or your dextrose, okay? The C6H12O6. This is just a sugar. There is nothing necessarily dangerous about this substance. I don't necessarily need to be wearing gloves for it. It's technically ingestible, but remember, in chemistry, we don't eat or drink anything in the lab. We don't know if I may have cross-contaminated this in some way, right? I was extra careful, but I still don't know if I had accidentally added a little bit of sodium hydroxide in there. We're going to add dextrose. And again, swirling till we have the mixture completely dissolved. And let's go ahead and get a temperature reading again. We're still sitting at 29 degrees Celsius. So we've still got a exothermic reaction occurring, but it hasn't risen any more so from where it was from the sodium hydroxide. So I would assume there's been no change. So far, this reaction is complete. I'm ready to add in the final ingredient, which is the methylene blue here. Okay. Now the reason we're adding this is because this is going to give us an indicator of a certain substance. And we'll talk about that here in just a second. We're going to add our methylene blue here. I'm going to add quite a bit. I'm going to try to add, 8 to 10 drops, maybe even 12. I'm not really going to count much here, maybe even up close. Every time I add drops of the blue, let's just add a good amount there. Notice that blue just goes away. I'm going to put a stopper on this because I'm going to try to vigorously shake that. Now we'll notice the blue was there for a bit, but then it went away, right? So let's do this again. Whoa. Interesting. Went away. Whoa. Happened even faster that time. And it went away. What's happening there? Let's do it one more time. What do you think the shaking has to do with it? What do you think it adds into the solution? For example, if I went ahead and filled the glass, the Erlenmeyer flask, all the way up to the top with this solution and shook it, I wonder if it would still work. The blue appears in the presence of oxygen. So if I filled this all the way to the top, would it still appear? So I want you to tell me a couple things in the comments. Number one, where do you think chemical reactions were occurring in this process? And then number two, what would happen if I filled this glass all the way to the top of the solution? Would this reaction still occur? Leave your comments in the below. Thanks, bye. Did I say in the below? you.